আর এই সপ্তাহে ফাঁকা সময় সবসময় একটু হ্যাঁ, হ্যাঁ, না। কোনো মানে না। ১০ না হ্যাঁ, করে দিতে। আমি দেখে বলব। একদম। শোন জয়ন, তুই না আম রংটা তো অন্য কাউকে দিয়ে করাসই না। এশিয়ান পেইন্টসকে দেখে আমি যা শিক্ষা পেয়েছি, ওদের ওই ইয়েতে অসংখ্য নাম্বার যেখানে পেয়ে যাবি এসবকে দিয়ে ওই অ্যাপয়েন্টমেন্ট বুক করবি, ওরা আসবে, কোটেশন দেবে, রং তো ওদের দিয়েই হবে। ওরাই সব ওই রকমই করবে। ৬০, ৬৫, ৭০,০০০ই করবে। হয়তো সে কথা বলে।
Good afternoon. I am Mir Kumar Singh, Chairperson of Future Leader Forum. On behalf of CEAI, welcome you all for today's webinar on engineering sustainability and rehabilitations of bridges and structures by our eminent speaker, Mr. Amitabh Ghoshal. Before going to the presentations, I would like to say something about the CEAI. Consulting Engineering Association of India, CEAI, is an apex body of consulting engineering fraternity in India. The membership includes small, medium, and large engineering consultancy organizations, both in private and public sectors, and established individual practicing consulting engineers. In addition, EPC organizations are also included in the membership, being involved in the planning, design, and engineering project and construction management as well. CEAI is the member association from India representing the Indian engineering consultancy professions at the International Federations of Consulting Engineers, FIDIC, on the global forum. CEAI received a prestigious award of FIDIC Member Association Excellence at the recently concluded Global Infrastructure Conference held in Singapore. Future Leader Forum is one of the committee of the CEI, which was formed in 2012 with the intention of providing young professionals with an opportunity to participate in CEI, FIDIC, and other SCI-specific programs and interact with their peers and help them to develop the next generation leaders. Future Leader Forum were entrusted to deliver webinar on various topics covering all fields of engineering. This is the 7th webinar series conducted by Future Leader Forum. This will give an opportunity to learn from each other and provide better field understanding to upcoming and practicing engineers. Now I would like to request Vice President Mr. JVL Narayan to say something about the CI activities. He is a civil engineering and transport planner by education and has about 30 years of professional engineering experience in consulting engineering business in the area of transportations, water, building, environment, and urban planning sectors. He has held senior level management positions, including managing director, resident director, president, senior vice president, head of the operation, technical directors in leading international consulting engineering firms like Royal Haskoning, DHV, Netherlands, WSP, Halpro, etc. prior to his current employment. Currently, he is working as a regional director, North with RV Associate Architect Engineering and Consulting Private Limited based at Delhi. He has extensive experience in working on planning, feasibility, design and construction supervisions of various transportations, water, building and environment projects. During his career, he visited many countries and worked in India, UK, Sri Lanka, Netherlands, South Africa and Vietnam. Please welcome Mr. JVL Narayan.
ঠিক আছে আমি তোকে ওই আমাদের নাম্বারটা দিয়ে দিচ্ছি ও বাঙালি লোক
Thank you. Good afternoon, everybody. It's been a very great opportunity for me to be part of this webinar, particularly the webinar topic and the person who is actually leading us today, Mr. Amitabh Ghoshal. I had the privilege of working with him. So you will hear and listen, learn from him a lot. Before just going to that, as Meher said, CEI's objectives are basically advocating global networking and cooperation. We actually promote quality development and promotion and production enhancement of consultants.
Okay.
Promotion of ethical practices is one of the key objectives of CEI. Facilitation and interaction with government and other authorities and bodies to streamline and improve the system of engagement of consultants has been one of the key objectives of the CEI. The other details have already been mentioned by Meher. But we must say that we are very proud of the CEI Future Leadership Forum. As he said, we are already in the 8th webinar. And we would be continuing with some exciting webinars going forward. But the Future Leadership Forum, has an excellent team of dynamic and talented professionals with very high ambition and goals of learning and growing. That's why you could see that there are a number of interesting topics that have been brought by some eminent speakers. We at CEI are proud of our Future Leadership Forum, and we encourage our leadership forum to conduct, participate, learn, and grow in their respective areas, including training and professional management organized by FIDIC. The Future Leadership Forum organizes meetings, webinars, workshops at regular intervals to in technical, financial, contractual, management, and all the aspects pertaining to the consulting engineering business. So as he said, we have already done 8, and some of them are exciting subjects are in pipeline going forward. The enthusiasm shown by this team in organizing a webinar with such an eminent speaker is highly appreciated. I'm also excited to see a large number of participation today in the webinar. And I'm confident that the webinar with the subject given would give a lot of insights for people to learn and understand, particularly through the experiences of Mr. Ghoshal. Thank you very much and best wishes to one and all.
Thank you, sir. Now I am going to introduce moderator of the session, Mr. Mirajuddin Ansari. He is a civil engineer by qualifications, and over the span of more than 8 years of experience in the structural design of bridges, he has expertise in spans of wide range of bridge types, including RCC, post-tension concrete, and steel composite structure. He has working experience for Bangladesh and others country also. He completed his graduation in civil engineering degree from NIT Tirchi. He is currently working in ICT Private Limited. Now I hand it over to Mr. Mirajuddin Ansari.
Thank you so much, Meher sir. And I'm very thankful to all the members for giving me opportunity to introduce such an eminent personality of civil engineering field, which is Mr. Amitabh Ghoshal sir. He is a civil engineer by profession. He is graduated from BEC, that is Bengal Engineering College. He is fellow of large number of professional institutions such as Institute of Civil Engineers, United Kingdom, Institute of Engineers, India, International Association of Bridge and Structural Engineers, Moreover, he contributes immensely to the professional publications of many codes of Indian origin. He has been responsible for formulation and publication of codes on many engineering subjects for Indian Road Congress and Bureau of Indian Standards. After working for internationally reputed construction agencies, BBJ, on the design and construction of bridges, he took charge of Eastern Zone of Stoop Consultant Private Limited, an Indo-French consulting organization with footprint in many countries in Southeast and Middle East Asia. He has played a very important role in exporting the Indian consultancy services to many other countries. Mr. Amitabh Ghoshal sir is past president of CAI. With these words, I would like to ask our eminent speaker to go ahead with presentation. Sir, the floor is yours. You can proceed with the presentation. Thank you so much.
Thank you, Future Leader Forum. I am grateful for having this opportunity of making a presentation, and I will only hope that you will find the presentation of some interest. I have based my presentation on my personal experience and involvement in some projects, and I look forward to, like all of us, I look forward to contribute towards the sustainability of this only world that we have. I would not waste time and just start my presentation. I start with a question. What, in the view of the engineers who are present here, is the most important global issue today? I'm pretty sure some of us will answer the gradually enlarging conflict between Israel and Palestinians. Some will think of the long ongoing conflict between Russia and Ukraine and all the world bodies. Some of us will think about the financial situation which is engulfing the world. But I'm very sure that if we go to a young child, he will have the only answer, and he will accuse us of the criminal neglect that we, the present generation, and well, I am an older generation, but you all who are younger generation are causing, is the root cause of this exploding impact of global climate change. You see, the world is changing, and every day, behind all these small happenings which are happening, war here and some catastrophe there, we are seeing that the climate is changing, and climate is something which is overbearing. We read that the glaciers are melting, the polar caps are shrinking, the water flow is going up, and more than that, which we can feel, the temperature is going up. We are having very difficult summer. We are having sudden rainfall and flooding. All sorts of things are happening. But the worst thing is that these things are not going to change, but they are going to be aggravate every year. And there will be very soon a time when the next generation will be bereft of drinking water. They will be bereft of the benefit of living a decent life, and their living will be crowded by the urge to survive and not try to do something positive. Now, having brought this situation, I think it is all of our responsibility to bring back once again the climate that we had, which had been worsening, but still was tolerable, and the only world that we have has got to be saved. Unfortunately, despite all the promises made by politicians and believed by us, there is a campaign launched by the industries who are trying to verify all this information as just senseless propaganda and not real threat. And it is their vested interest to keep us blind to the situation. But meanwhile, the phenomenon is becoming irreversible and an emergency action is required. We are engineers and we are the foot soldiers of civilization. If we cannot change the situation, nobody can. And therefore, to all of us, this should be the primary aim in our life. Every day, every moment, we should think of this. Question is, are we doing enough? Now, Government of India has committed to reduce carbon intensity by 45%, achieve net zero emission by 2070. We have great faith and we believe that this will be done. But then are we contributing towards it? Are we engineers concerned about it? It is not the politicians' task only. It is the task of us engineers who are day-to-day responsible for every development and every deterioration that the world is having. In the construction field, we all know that the construction sector in our country contributes 12.75% of the carbon emission. You can see the breakup. And at least we engineers should be able to help in this area. How can engineers help? We can help by reducing operational carbon and embodied carbon. Embodied carbon is which goes during the manufacture. Operational carbon is the carbon consumption during the utilization of the facilities. Now, to achieve this, we have got to choose a material which will have less embodied carbon. We have to plan such that the operational carbon or consumption of carbon dioxide, emission of carbon dioxide is reduced by better utilization of the facilities. We can avoid distress and the limitations on operation by proper design and, more importantly, the appropriate maintenance protocol. We make something, we design something, but we don't guide how to maintain. What are the importance of maintenance? It is, after all, we engineers are responsible to ensure that the structure we build is properly maintained. And then, when a structure shows signs of deterioration, it is we engineers who can increase the life of a structure and add to its sustainability. If we can increase the life of a structure by 10 years, we are deferring the construction of the new structure by 10 years. And to that extent, we are sustaining our world. The materials to be consumed are all irreplaceable. And if we can delay use of the material, we have done our bit. By it is our contribution, it will become our contribution to the future generation and will make engineers relevant for the world. Now, what is maintenance? Maintenance of a structure that we build. It requires maintenance, just as human body needs. And human who is active can continue to be active if he is maintained properly. Now, in case of a structure, what are the distress? What are the causes that cause bad maintenance or that cause distress? You know, in concrete, we know there is a shrinkage and resulting crack. We know there is temperature stress which causes crack. When there is a crack, it allows the structure to absorb moisture, to absorb chloride, and that goes and corrodes the reinforcement. And if it is steelwork, it corrodes the steelwork as well. Then we put a structure to overloading. There are vehicles which are improving every day. Earlier, truck used to carry 10 tons, 15 tons. Today, trucks are carrying 40 tons. And this overloading and the concentration of load are not being taken care for a structure which has already been built. Then there are external influences, like which are natural phenomena, earthquake, high wind, fire, cyclone. All these are contributing towards bad maintenance and reducing the strength of a structure. And I'm very sudden it appears that vegetation, which we are all looking for, that we should have more vegetation in the world. Now, vegetation is one of the worst enemies of a successful structure. What you are looking at is a running bridge. People are crossing. All types of transportation vehicle, including passenger vehicle and goods vehicle, are running over it. And people are very happy it's a good bridge and it is providing them means for transportation. But hardly anybody goes underneath the bridge. And you look at the underneath of the bridge, look at the vegetation on the right-hand picture. You can see that the pipeline is being supported on the stem of a people tree which has grown with the cracks which has happened in the structure, and some seeds have been dropped and a tree has grown and nobody is taking care. And in the process, it is not only corroding the structures, it is also causing spalling of concrete, exposing the reinforcement. And you can see people are living on the left-hand picture. You can see there are people living under the bridge. They are having their day-to-day course. They are cooking there. They are putting fire there. And all that is deteriorating a structure which we have built for 100 years. And we expect that to survive for 100 years. But how can it survive if we do not take responsibility for its maintenance? Now, in terms of recovery of a structure or strengthening of a structure, there are three stages which we talk of. One is repair. When we find that a structure has deteriorated, we try to repair, we try to bring it back to its original shape and its original strength, so that the functioning is not impaired. Repair is not for improving the structural strength, but for bringing it back to its original design situation. Now, the other thing is rehabilitation. When we find that just normal repair would not do for it, you have got to upgrade or change the structure to bring back its original functioning. But when we do a rehabilitation, we have got to be sure that the rehabilitation measures will not be costlier than building a new structure. Unless we find that rehabilitation is going to be economical in short term as also in life cycle cost, it is not worthy for going for rehabilitation. The third term we hear is retrofitting. Retrofitting is re-engineering. Re-engineering by adding new material or new structure, changing the play of forces, and thereby improve the performance of the structure so that it does not deteriorate, so that it functions up to its anticipated lifespan. Now, all these are the engineer's contribution towards the rehabilitation of a structure. And it is that by which we can contribute towards sustainability. I shall, try to understand, share with you what are the reasons for these needs for repair, rehabilitation, or retrofit. One, it could be an inadequate design or detailing and poor construction, even when the structure is made. It is not unusual with our tendering system, our emphasis on least cost. It is quite possible that people willingly or unwillingly try to keep the structure under design. And with quality of construction being sacrificed, it can cause ultimately deterioration for a structure. Then there is local damage, which can be caused due to accident, negligence, or just some sort of a unexpected happening. There is serviceability deficiency in a structure due to excessive deflection or vibration, which is caused due to the slippage of the joints and splices. It gradually starts vibrating and people are scared of using the structure and they underuse the structure and thereby reduce its effectiveness. There could be increase in design vehicle loads, as I was mentioning. There is improvement in automobile industry and they are making one vehicle to carry more load, thereby making it more economical. But they naturally cannot think of the structures. It is our responsibility to think that if the vehicle loads go up, we should look after whether the structure we have built, the structure which is giving us service today, will still be safe or unsafe. And we should know about the impact. Very often, there's a bump in a structure and that gives more impact. Continuous application of impact impairs the load carrying capacity of a structure. Then codes are a result of improved knowledge of human beings. Every day we are learning more, we are making new developments, new improvements, and in the process, our engineering capability is increasing and we are reflecting that in our code. Today, all of us know that seismic codes are going through regular change. Because our knowledge is increasing, we are analyzing by record, analyzing the big data, we have found out that the earthquakes behave in a different way than you knew. Wind behaves in a different way than you knew classically, and therefore codes have to be changed. Now, changing the code is essential, but to check the structures for the effect of the changed code is an essential requirement of the engineers who look after the structures. It has to be mandatory for us to check the structures. Then, of course, there is atmospheric effect. With more pollution, with more chlorine, with more carbon, we are having carbonation, we are having corrosion, and structures are deteriorating. Then there is fatigue effect due to long-term use. It is gradually getting worse and worse. Absence of structure inspection protocol is one of the main reasons for deterioration of structures. And we would try to understand, I would try to share with you my understanding of these issues by sharing with you some of the case studies, which one of them involves repair, the other involves rehabilitation, and the third one involves retrofitting. So I think instead of trying to just lecture, giving dry facts, let us share some of our experiences. The first one I am going to talk about, these are all involved in the eastern region and the city where I live, or the eastern region. This was in Calcutta. There is a boasting bridge across a canal. The canal, interestingly, is called Maratha Ditch because the Britishers had built it to keep away the Marathas who used to come all the way from west to Maraud and to loot the wealth of the peoples living here. with a 25-meter span boasting girder, constructed in concrete, completed in 1934, with nominal mix 1 to 4 mix concrete and MS bars. We had this structure now almost for 80 years, or more than that, 90 years. And this has shown some damage in the concrete hangars and deck structures, which came in the form of a special inspection done of the bridge. Now, restoration was done by replacing the hangars with McAlloy bars and use of carbon fiber strips on repaired concrete. I'll just share the case. You see, as you know, the boasting girder is one of the classical structures which is used for reducing the depth of the deck so that the formation level can be kept low, the clearance from the underlying water has to be provided. But then if we can keep the depth low, we require less sort of grading in the approaches. And it's a pure structure because it takes compression in the top chord and tension in the bottom chord. There is very little bending in the structure. And the verticals are hangers which hold the deck. Now this was, okay, whatever is shown in green is what was proposed to be used with carbon fiber. And here we show further details. The underside of the deck has been, can you see the this mouse arrow, or it is not visible? Is it visible? Okay. Okay, so these green things are the underside of the deck, which has been put with carbon fiber ultimately. And you can see on the right side, the hangers, the vertical hangers are dumbbell shaped, and these have also been covered with carbon fiber. And this is how the hanger is hanging. The underside of the deck you can see here in the green, and this is the entire structure. Now, this is the bridge as it was just before repair. And on the right-hand side, bottom, you see the bridge immediately after repair. The repair was taken on an emergency basis because it was found during inspection that these verticals, concrete verticals done in 1934, had the wave of only 20 centimeters, leaving the cover to be only 60 millimeter. And therefore there had been damages and spalling of concrete in the verticals. This is what attracted the attention, and then we did inspection of the underside and then took up the repair work. You see, you can see the verticals, as I said, have been replaced by these McAlloy bars. Each vertical has been replaced with 4 McAlloy bars, which have been placed on the top of this rib, and put such that vertical load is transferred onto the top rib, and then you connect it to the bottom and lift it, put nuts. Now this is the quality of damage which were found. You can see the reinforcements are fully exposed. These are the mild steel bars, and they are fully exposed and in a condition where they will just deteriorate, and the bridge was ready for sudden failure. You see, this is how repair is being done with micro concrete for the damages which were there. And then, as I said, McAlloy bars are put on the top rib arch, and this is how, with a steel plate, the load is being transferred, and in the bottom, with threading arrangement and nuts, the tension is being transferred from the hangers are being transferred to the new bars which have been put in. And this is the condition of the underside. You can see the slab bottom, as you can see the bottom of the beams of the deck, and all that had to be cleaned, new concrete put in, and then this is how carbon fiber, you see, carbon fiber is being put onto them, alternate, and then fully covered. And on the right hand side, you see the carbon fiber covered with plasters, and the repairing is complete. This is the load testing being done, and it was found to be in good shape. The bridge was in good shape. And by repairing on an emergency basis, not only we have extended the life of this bridge, but there was a major repair going on in an upstream bridge, which is a much longer bridge across railway yard, and that repair could not be taken up unless traffic could be diverted on this bridge. And it carried all the traffic and thereby allowed that other major repair to be completed. Now, what are the lessons learned? As usual, appropriate inspection and bridge monitoring can save distress. A lesson we have been taught, but we have not learned. Application of new technology like carbon fiber, like application of baccalaureate bars and pre-tensioning them and thereby taking the load off of in a old structure can give it new life. But one caution, such specialist work should be done by experienced organizations and not by just ordinary tendering and giving it to the lowest bidder. One should be cautious about that as engineer, and a very close scrutiny and supervision is required during the implementation of the repair work. I move to the next case. It's a bridge across the Howrah station. You know, Howrah station has more than 20 platforms, 24 platforms to be exact. And it is a station which does not cease working throughout its day. It's hardly 4 hours at night that there is respite from trains moving in and moving out. And since this railway track divides the city, you know, the only link between Calcutta and Howrah is over this deck. As you can see, the traffic is moving on this, and you can see the trains all underneath, either, you know, they are in a sort of stationary condition, loading passengers or leaving. And this is the condition, you know, the gap between the underside of the bridge, underside of the viaduct, and the high tension wire which runs the electrical trains are hardly 60 centimeters. So no place at all for going underneath or repairing them. Is there some, is it somebody talking? Hello? Hello? Okay. Well, some brief particulars about the Pankim Setu, as we call it. It's about 300 meters long, 9 spans. Spans vary from 21 meter to 42 meter. And carriageway we go into 9.9 meters, 6 lane carriageway. And superstructure composes of 9 PSC beams and gap slack. The type of damage was cover concrete at the soffit of the girders had spoiled. It is a PSC bridge. PSC precast girders were cast and put in place. The sheathing tubes and the cable ducts were corroded. The PSC strands were exposed, corroded, and snapped. This is how the underside of a girder of the bridge, which is carrying continuous traffic day and night, started. You know, you can see the concrete is just falling off. It does not look like concrete. It looks more like plaster. And this is what the next stage. All the plaster has gone away and the pre-stressing wires are hanging like this. And this, mind you, in a city where it is under the view of thousands or millions of people who are using the station If they look up, they can see the condition of the girder, and still they had remained like this without any repair for a very, very long time. All the bottom layer of precision cables are exposed without sheathing, grouting practically absent, and bottom layer of cable snapped. I don't know how well you can see, but these are the 9 precast PSC girders with a little bit of gap slab, 9 girders side by side placed, that and very little, very short girders, so that the formation level could be low. And this is how the bridge had been designed. It's an excellent design, but only thing, the designers did not think about the maintenance part of it. These are all precast girders put in place with very little gap between the end of the girders, and therefore you could never go and see the end of the girder, how the pre-stressing anchors are there. And this is the cross section of the girder. You can see there are 22 cables. Now this 22 cable has been neatly arranged, but the only problem was that the gap between the cable was hardly 30 millimeter. Now for a girder which is almost 2 meter deep, 2.4 meter deep, you see the concrete is being poured from the top in a encased shuttering. And when the concrete reaches here with a 30 millimeter gap, the concrete does not flow. What has flown is just the plaster. A sand cement slurry has gone in. The concrete stone chips have formed neat arches, and therefore underneath what you saw is more of a thin layer of plaster rather than concrete. And that has caused the decay of this bridge in hardly 20 years' time after it was built. And all these days, because the road is the user of the bridge and railway was the upkeeper of the bridge, so none of them looked at the condition of the girders. Now the solution which was offered, of course, was remove the concrete, replace it with micro concrete, expose the sheathings in weak concrete zone, replace the corroded sheathing, grout all the bottom sheathing, and then external pre-stressing. The only other way was use of carbon fiber, but in those days, in 2000, carbon fiber was not that popular, nor was the technology well understood. That is why what we took recourse to is external pre-stressing. Because mind you, as I said, there are only 4 hours of stoppage time. And during these 4 hours, work had to be done if you have to go underneath, because otherwise, with 13,000 volt, nobody will survive. So this is how the repair could not be done underside very safely. And that is why external pre-stressing was done. You can see the pre-stressing cables which are being taken and embedded. They are being passed through steel members which have been embedded in the concrete, and through them the pre-stressing cables have been brought, and they were pre-stressed to replace the corroded and damaged pre-stressed wires which had been, as you saw, converted into sort of like old electrical wires hanging. And with this pre-stressing, the girders were replaced or restored, and the engineers, after doing the job, gave the assurance that with this sort of a repair, it will live for another 20 years maybe, but you have got to look for a permanent replacement. The work was done in 2001. Now in 2023, railway has started thinking of replacing the girder with a new bridge, but it has gained a time of 23 years and delayed the new construction by 23 years. And that is our contribution to the sustainability. The conclusion, or the awareness which came, again, quality control, which was poor. I mean, even a wrong design is a poor quality control. Where you do not leave space for the concrete to flow is poor quality. The importance of proper grouting obviously was not emphasized. The cross-section of the girder which had been selected, and in an area which is prone to atmospheric pollution, because thousands of trains are coming in and going out, the dust and the diesel and fumes and all sorts of pollution that comes with huge movement of people were not thought of. The detailing was not proper, and unfortunately, there was no periodic inspection and reporting. Railways are famous and very well respected for good maintenance. But when it came to maintenance of a road girder on top, they were not actually that careful. It's sad, but it is true, and this is what we engineers work for, and this is how we can contribute. The third project I will take up of retrofitting, it's an old job, classical engineering job, but I am always proud to talk about this job because it is one of the finest examples of work done by Indian engineers in a foreign country. What you see is a bridge today in Bangladesh. At the time it was damaged, it was in Pakistan, East Pakistan. And this is a bridge across Ganga, the main Ganga or Padma as they call it. It's a long bridge and it carries 2 lanes of broad gauge railway, the only bridge across the river for railway in that country. Bridge had been contemplated in the 19th century, 1889, and was completed. Construction was completed in 1915. After it was started, go-ahead was given in December 1908. Those were the days of bridge builders. Sir Robert Gale, who was the engineer-in-chief, he was the bridge builder. He was responsible for everything from design, planning, design, construction, look after his workmen, to get the proper workmen, to select the proper tools. Everything was done by him. And it was completed in 1915, one of the finest examples of long span girders. These are 300 and more than 100-meter girders, 345 feet to be exact, and it's more than a mile long. It consumed 27,000 of steelwork and some 300,000 tons of masonry in the piers and the wells. It was all done in brick masonry with concrete fascia block. And this bridge got damaged during the brief 1971 war between India and, India tried to help the population in East Pakistan. And in this process, Bangladesh was born, but the bridge was the casualty. There are 4 damages. You see, one of the piers were damaged, but these are steel columns filled with concrete, and it is that concrete which saved the pier from collapsing. And you can see the right-hand side, the damage to the span 9. It is 75 feet or about 23 meters of bottom cord was blown off. The deck was blown off. The cross girder and the stringers have been blown off, and the bridge had tilted and sunk. And you can see more detailed situation, how the members have been, how the bottom cord has been buckled. I'm sorry for the poor quality of pictures. I had to take them in a Brownie camera with which I visited. And then there are the diagonals and the verticals which were damaged. There's another span which had been dislodged with dynamite and fallen down. I will not talk about that. But this span 9 was because if a span has fallen, you have to replace it. But if a span is damaged, you can still try to restore it. And that is what was done. Now, this bridge had a significance more than just a railway bridge. Because for the newly formed Bangladesh government, the head of the state made a personal request and a passionate request that the bridge should be restored as very quickly, because Bangladesh had only one product which it could export and earn from the international market, that is by exporting jute. And the jute had to be exported through the Mongla port, which was on the western side of the river, and jute is grown on the other side, eastern side. And only if this bridge is restored, then jute can be taken to the port and exported across the world, and Bangladesh can earn some well-deserved honorable foreign exchange. Bangladesh was living on doles and on grants and credits given by various agencies and countries. So he made a request, and Government of India took up the task, and it was something virtually impossible, because the work was given in February and the job had to be completed in September. Now, it's a country which is totally in a dismay. There is no infrastructure. There is not even a single welding shop or a welding facility. No tools were available. No crane was available. No equipment was available. And most of the part was inaccessible. It only had hungry people around. No other facilities. And undertaking a repair of a girder which weighs 1,600 tons, each span was weighing 1,600 tons. And to repair that, to hold that and support that was virtually an impossibility. But Indian engineers took up the challenge and decided that, okay, the trestles for the piers can be repaired easily. The span 12, which has suffered, which has fallen down in the river, the span has to be removed, and the temporary span has to be put in place. That was also decided, and for that, some ongoing bridge spans were taken from India. But it is span 9 which presented the toughest challenge, and it is a span which has deflected and which has tilted. The bearings have been dislodged. The upstream truss showed 0 camber, and the downstream truss had a negative camber of 6 centimeters. It was not even known. This is the schematic view of the girder. What you see that here in the dotted line is the damaged side camber, and what you see on the other side is the good side camber. The only positive thing about the bridge was it had very stout bracing, which were redundant. Top chord bracings, they were intact and they were very, very strong, and there were sway bracing. So one side truss was holding the other side truss, you can consider more as a cantilever through those bracings and the particles. That is how, but it was not known whether the members are safe, whether they have crossed elastic limit or they are still gone to plastic limit, in which case you cannot use them as a bridge. And in those days, in 1972, India had only one mainframe computer at IIT Kanpur, and getting time in those computer centers were very difficult. And 1.5 hour slot was given at night, 2 o'clock, and we had to go and do the analysis of the as-is structure, considering all these members removed. And it was found to our relief that no member has crossed the elastic limit, and therefore one can really try to restore it. And well, I think I'm still within time. Another 10 minutes I have, I suppose.
Yes, sir.
Okay, now what are the constraints? The river was very deep, more than 60 feet in monsoon, and the river water was flowing at 8 feet per second, or I'm sorry, I'm talking in terms of feet, 2.5 meters per second. And water rises 60 centimeters every day during the month of June and July and August. Hydrograph showed that. No heavy items like cranes could be moved along the trek. till, this repair was done. The efficacy of the undamaged members was proved, and for commencing repair work, the span needed to be restored to its nominal shape. You cannot repair a deformed structure. You have got to bring it back to its original shape before you can undertake any repair work. So that was the biggest challenge. No support could be provided from the river bed because it was 40 feet of water, and then there was silt. No floating cranes were available which could lift the span. The cable stayed system, if we put a tower on a pier and then put cables and pull that up, was not possible because that would require very long time. No heavy lift equipment was available in India or in Bangladesh. If we had a floating crane with a huge capacity, it could have helped, but it was not there. So we had to go back to the elements. We had to go back to our basic thinking, and it is left to the designers how to do it. We studied the original erection scheme. The bridge had been erected, the girders were fabricated on the bank, then it was floated out on barges and then put in position. So we thought, why don't we get some barges? We are fortunate, we got some barges which have been spared by railway. Farakka barrage has been completed, so these barges which were used for ferrying wagons, 20-ton wagon, that means they can carry 400-ton load. So those barges were brought in, and it was found out that if we can jack the span at 1/3 point with 300 tons, then the span will come back to its original shape. So that's what we did. We brought the barge in, for delivering this 300-ton jacking load, we followed the principles of buoyancy, the Archimedes principle. These barges were steel barges and inside was hollow. So we filled up with water, and if you put it under the span with a strut, then if you fill with water and pump out 300 tons of water, it will put a jacking force of 300 tons. And once the span recovers its shape, you can connect it to the adjacent spans and then hold it by cantilever, and then you can repair the damage. This was the scheme of things. Looked rather wild. Railway did not approve the scheme till the work was completed. The barges were strengthened by introducing bulkheads inside and welding them in situ. Barges were tested for carrying this centrally applied load. Top chord and rear end joints were opened out and for connecting to adjacent spans, and trestles were erected on the barge to deliver jacking force. After all this work was in place, it was jacked first. So when the river level already started rising, it was connected on to the adjacent spans, and then all the damaged members were removed, new fabricated members put in place, and the final closure was done by doing the splicing in situ. I will just show you the scheme. You see, this is the span, damaged span. You can see the damages. And two barges which have been strengthened were brought in. They were anchored in the river bed with cable anchors. And then on those barges, this trestle, steel trestle was built up and connected onto the bottom of the girder. You see, so we have put two supports at the 1/3 point, and then we filled up this barge with water, pumped them out so that 300-ton jacking force is put, and then we have removed all the damaged members. First of all, before that, we connected it with a tension link and the buffer, compressive buffer at the bottom. We connected them to the adjacent span so that this half of the span is cantilevered from this span, and this half is cantilevered from the other span. And we are free to remove all these members and the repair could be done. Sorry. Again, apologies for the poor picture. You can see people are erecting the trestle on the barge where, strengthening has been done, and the barges were put underneath and the assembled. And then, this is how the barges have been put, and there was no electricity, only with generator we were working. There were no, communication system. So we worked with handheld megaphones and gave direction for people working in these corners so that they could connect it on when the thing was jacked up. Now, first jacking was done and the removal was done, and then the bridge was ready for final repair. But we found that the trestles are now too long because water has risen by more than 8 feet. So we had to cut down the top part of the trestle, make new grillage, and then again, once again, the span was jacked up and it was brought to its original position. And then the final joint was done by making the last splice in situ. And when the span was finally released from the links, we found that it has restored its camber, and our the gamble has paid off. Whatever risk we had taken had proved to be okay. So the work had to be done, as you can understand, because we are working in monsoon and we were working to achieve completion by September. So it had to be done day and night, and everybody in the team was contributing towards completion. Ultimately, we won the race against the river, and the time and final work was done in mid-July to make the track through up to span 12. And once the track was through and the new span brought in and put on the span 12, traffic could be restored and railway could run their trains with jute in end of September, in October. It was one of the proudest moments of Indian sort of engineering people at that time. Now, lessons learned that repair and restoration work needs reverse engineering. You have got to go back, understand how it was done, and then make innovative planning. The safety of structure has to be ensured, and people at every stage. It was in a risky condition when the bridge was hanging like that and you were pushing it up from the river. It could have collapsed any time, but one had to be very, very careful. And different work protocols had to be involved. It was more of a social engineering. We had to make every worker put his best, and that is how this astounding work could be done. And it was acclaimed very well by the engineering community in UK and USA, both of whom had refused that this repair work cannot be done. And they had given the verdict that there will be a failure. This is the condition of the bridge today. I was invited to attend the 100th year of this bridge. Now it is 50 years after repair that the bridge is running, and twin track broad gauge trains are running across this bridge. So by doing this repair, we have deferred the new construction or major work by 50 years. And that has been the contribution engineers can make towards sustainability. So it is for us to take every repair work, keeping in mind how we can help the ultimate sustainability of structures, ultimate sustainability of our world. Now, these lessons through the 3 case studies that we have done, I have just tried to put together the way forward. You see, first, I think the government and the people have to understand that maintenance is an operation which requires money. You must have budgeted money for maintenance, which no budget provides for. We provide budget for new construction, but we don't provide for maintenance. Formation of a defined team who is responsible for maintenance, for upkeep of the asset, has to be done. And these are not engineering, but these are essential for engineering. Then the technical manpower has to be have specialized training. Restoration is not taught in any engineering college. Restoration or rehabilitation is not part of our curricula. So one has got to learn for examples. We should have in colleges such case studies described to students, and the engineering cadre should have training in such work from time to time. We must have strict and effective checking of the design and detailing of the structures to ensure that they have been properly built, they are not poorly detailed, they will not contribute to deterioration. There has to be regular and dedicated supervision at the construction site with testing facilities for checking of quality of material. This is where most of the mistakes are done. Even the second Vivekananda bridge, it had been, while it was being built, during construction, it was found that the steel which had been imported was laminated. So constructed cross girders had to be downloaded from the bridge. Now, ensure regular and dedicated supervision with testing facility. Then the space below every elevated structure has to be kept free from people, free from plants, and should be used only for neutral use like gardening and beautification. There should be arrangement for systematic training of technocrats on structural design, detailing, and rehabilitation measures. And for continuous monitoring and upkeep of very important and major structures, one should consider appointment of specialized agencies. In USA, they have firms like T.Y. Lean looks after the Golden Gate Bridge. The Steinman looks after, the Brooklyn Bridge. Like that, task is given. Maintenance is a living task, not a spare casual task. That is most important. And I think only through that we can achieve sustainability and maintenance of our structure for longer period. The three cases I mentioned, the first one which has just been completed, we are all pretty sure that at least 10 years his life has been extended. The Howrah Bridge case, Howrah Station case, it has already lived for 23 years, maybe another 5 years it will live. And this bridge, last I showed, has lived for 50 years. So this is our humble contribution towards sustainability. And I would request all of you to keep this in mind whenever we inspect and repair the structure. Thank you very much.
Thank you so much for such an explanatory presentation, sir. It has been a very learning experience for me, especially being a bridge engineer. And I have learned a lot from this presentation, just because the way you have presented it with the examples, the three examples, one of Howrah Bridge, another is Padma River in Bangladesh. And it was a very explanatory. And I would ask the participant if they have any question, they can go ahead, unmute themselves and ask the question to sir, or they can type their question in chat box. I'll just take a pause of 10 seconds for a question. If nobody asks, I have a question for myself, which I have been facing in past when I have been there with the MBIU for repair and rehabilitation, or the new stretch if it is open. Then these days now there are cycle of there are 6 or 7 cycle of inspection for the new bridge for how it has been constructed. So this clarity I would ask. Please go ahead, sir. Ask if anyone having any question.
I think one Mr. Probit Datta has raised his hand. That's what.
Yeah, yes, sir. Sir, please ask your question, sir.
I think you have to put in. You have to allow him to talk. He has to be mute. Has to be removed. No, otherwise he can.
I have removed.
Yeah, audible.
Yeah, sir. You are audible.
Very much.
Please go ahead.
Good evening, sir, Mr. Ghoshal.
Good evening. Thank you.
How are you, sir?
Well, let us,
This is not the question.
yeah.
No, though I am a mechanical engineer, but I have to do some kind of structural, in conveyor, in cranes and all, design and erection. What you said actually, I have no word to give you praise, neither have the guts to give you any praiseworthy sentence. But my question is, now we have to have these flyovers, bridges, steel structures, cranes, conveyor structure, building structure, workshop sets and all these things. But in my 55 years, you are much more experienced than me. In my 55 years of experience, my feeling is that no organization in India, whether even you have talked about railways, nobody is interested in maintaining these structures. Nobody is interested in maintenance of structure. So I suggest to CI through you that there should be some session on maintenance. You have given case study. We know, most of us know those who are interested in this kind of thing and associated with CEI, and they update about engineering. But even small organization and the largest organization, some aircraft, the door is open while you are flying. Somewhere the wings, some part is flown away. So I think people should give, design is one aspect, construction is another aspect, but I think maintenance is the most important aspect. What is your idea about it, sir? What do you say about
As I
it?
have already mentioned that, every project should have fund allotted for maintenance. I will give you a classic example. The Howrah Bridge, old Howrah Bridge in Calcutta. It is more than 90 years and it is in very good shape. Why it is so? Because every municipal taxpayer pays 1.1% towards the maintenance of Howrah Bridge. All that money is rested with Calcutta Port Trust, who undertakes the maintenance of the bridge, and that is why there is a continuous spate of maintenance with a team allocated. That is the only way one can maintain a bridge. You see, the second defect of the bridge is a toll bridge, but the toll money does not go for maintenance. There is no budget for maintenance. You have no budget. If you have no person allocated, maintenance cannot be done automatically. It is not a casual.
Incidentally, I worked in Calcutta Port.
Yeah.
You know Calcutta Port. I was in Calcutta Port. Then I came out of that and I did the consultancy.
Okay. Any other question?
Sir, I have a question of myself. The first thing which you are showing the repair and rehabilitation of the Padma bridge, steel bridge.
Which one?
What was the Padma River steel bridge repair and rehabilitation? Sir, what was the safety measure that was taken for workers that were working on the deck of the waterway?
What was the? Sorry.
What was the safety arrangement, and in general, what is the safety arrangement for a workers working on a repair and rehabilitation work, as the bridges are generally very weak in strength? That's why they are being replaced.
Basically, this was done in 1972. And at that time, the safety arrangements were very limited. Safety used to be controlled only by the engineer in charge. You see, we used to go on traveling, go on visiting in the bridge, looking after the safety. There was no established, there was no safety officer, there was no safety belts. People used to look after their own safety because they knew that if they fall, it may be fatal. And unfortunately, no safety arrangement was there. Today, you see, even when the Howrah Bridge was built, safety arrangement was only left to the individuals. But today, repair work is going on the Vidyasagar Setu, and there is a safety officer, there is a safety team, there are safety belts. The moment you enter the area, you have to put a hard hat, a sort of helmet, and you have to take a belt if you are going down. Now, those things were not present at that time, I'm sorry to admit.
Sir, I have one more question, and this will be the last question because I have not seen any participant raising their question. The question is, how do we come to a conclusion that this bridge is to be replaced wholly? It cannot be repaired. This is the one question. And the second question is, how do we come to know that this bearing has failed and we need to replace this bearing?
How do you come to know?
How do we decide that our bearing has failed and it needs to be replaced?
Okay, you see, first question you asked about how do you know that a structure cannot be repaired and has to be replaced? Well, if you have not been able to devise a repair scheme which is financially attractive, you know, if you want to repair a bridge, if with say 10 crore of rupees, and if you find that a new bridge can be built with 9 crore of rupees, you will naturally go for new bridge, unless you know the cost of traffic diversion, etc., proves to be more preventive. So it is a question of analysis, the financial analysis and the benefit analysis. That's how you come to that conclusion. As regards bearings are separate item. You can always jack up the span, take out the bearing, test it, and then find whether it has been permanently damaged or not, and use it. That is the best way.
So we can't decide with the naked eye that whether it is damaged, it need to be replaced. It has to be tested. That then
we come to know. You know, if it is a steel bearing, you can remove it and test it. If it is a sort of neoprene bearing, you can see from the condition whether it can. In any case, it has a limited life of 25 to 30 years. So okay, you have got to replace it if its life is over.
Okay, this is it, sir. And it was a nice interaction with you. And with this, I would like to ask Mr. JVL Narayanan, sir, if he is available for his closing remarks. If
Pardon?
There is any.
In the chat, I find only one question, request that the presentation can be shared. That's for the organizers to decide whether you are going to share it. I have no problem. I believe in giving away knowledge rather than keeping it to yourself.
Yeah,
you know,
sure.
So I have no problem. And there are no inspection. Somebody has asked whether there is any inspection tool and standard sheet for bridge inspection. You see, every bridge is different, so there cannot be a standard sheet. Yeah. Okay.
Mr. Narayan, sir, please go ahead.
Right. Thank you very much, sir. Sir, I think it has been a quite insightful presentation from your side, bringing in all the lifetime experiences that you have. A lot to learn. I have had the opportunity to work with you and still learning from you a lot of new things. I must express real hearty thanks from the entire team of CEI for your great initiative, particularly at this age, coming out, and that is the reason why we call you Tama, and also for the sort of the knowledge that you have. The title is quite eminent, and then also in terms of the Lifetime Achievement Award for the extraordinary work that you have done in this area. So on behalf of the entire team, it was a fantastic session, a lot of new things to learn, and I express my sincere thanks for your time. Thank you very much.
Thank you. Thank you so much, sir.
Thank you.
Thank you, sir.
Some firm ground, because this is all very soft. So now they are not doing ground improvement. No, that's what I understood. So this is like a structure. It will take care of what is this perspective thing.